Welcome to the Enterprise AI Leadership Series on my YouTube channel. When organizations discuss AI transformation, the conversation usually focuses on models, algorithms, or the latest advances in generative AI. However, the biggest obstacle to enterprise-scale AI is often much less visible. It is the architecture underneath the organization. Most legacy environments were designed for transaction processing, operational stability, and regulatory control. They were not designed for real-time intelligence, continuous learning, or AI-driven decision-making. As a result, many enterprises discover that AI pilots can demonstrate value, but scaling those capabilities across the institution becomes significantly more difficult. The key message of this presentation is simple. AI maturity is increasingly becoming a function of architectural maturity. The limitations we encounter around governance, explainability, deployment speed, and operationalization are rarely model problems. They are structural constraints embedded within legacy technology landscapes. Understanding these constraints is essential for any executive seeking to move beyond experimentation and towards sustainable enterprise AI adoption. If you find these enterprise AI discussions valuable, you may consider subscribing to my YouTube channel for future deep dives on leadership, transformation, and AI execution. Let's begin. The challenge begins with a fundamental mismatch between what AI requires and what legacy systems provide. Modern AI systems depend on real-time data flows, modular services, runtime governance, and continuous observability. Legacy environments, by contrast, typically rely on batch processing, tightly coupled architectures, manual compliance processes, and static operational models. The important point is that these gaps do not exist independently. They compound one another. Batch data delays decision-making. Monolithic architectures make model deployment difficult. Static governance frameworks cannot provide real-time oversight. Limited telemetry prevents organizations from identifying drift, degradation, or operational risk quickly. The result is not simply reduced efficiency. It creates a structural ceiling on AI capability. Organizations may possess sophisticated models, but without the supporting architecture, those models cannot consistently deliver value in production environments. Across industries, three architectural constraints repeatedly emerge as barriers to AI operationalization. The first is the tightly coupled monolith. In many organizations, core systems remain highly interconnected, making even small changes difficult and risky. AI deployment therefore becomes dependent on lengthy release cycles. The second constraint is batch-first data architecture. Data often moves through scheduled processes rather than real-time event streams. This creates latency between business events and AI-driven decisions, reducing effectiveness in use cases such as fraud detection, customer engagement, or operational optimization. The third constraint is static governance. Traditional governance processes were designed around periodic reviews and reporting cycles. AI, however, requires governance mechanisms that operate continuously and at runtime. What makes these constraints particularly important is that they reinforce one another. Solving only one of them may improve performance, but it rarely creates an AI-ready enterprise. This framework summarizes the four most common architectural barriers organizations encounter. First, monolithic architectures restrict deployment agility and prevent rapid model evolution. Second, fragmented data estates create inconsistencies between training environments and production environments, leading to degraded model performance. Third, brittle ETL pipelines introduce delays that undermine time-sensitive decision-making. And fourth, governance frameworks designed for periodic oversight struggle to support real-time policy enforcement and auditability. Many organizations interpret operationalization challenges as failures of data science, model quality, or talent capability. In reality, the underlying issue is often architectural readiness. This explains why AI pilots frequently perform well in controlled environments, but encounter significant resistance when organizations attempt to integrate them into core business operations at scale. Enterprise AI introduces several requirements that legacy environments were never designed to support. The first is continuous telemetry. Organizations need real-time visibility into model performance, latency, drift, and reliability. The second is model provenance, ensuring every decision can be traced back to specific models, datasets, and features. Third is real-time explainability. Regulatory and governance expectations increasingly require explanations to be available at the moment decisions are made, not reconstructed later. Fourth is event-driven decisioning, where AI responds immediately to business events. Finally, there is distributed governance, where policy enforcement becomes embedded directly into operational workflows. Collectively, these capabilities represent a shift from traditional enterprise systems toward AI-native operating environments. They cannot simply be configured into existence. They must be designed into the architecture itself. As organizations pursue AI transformation, they encounter three recurring tensions. The first is speed versus architecture. Business teams want rapid AI deployment, while architecture teams emphasize long-term sustainability. Moving too quickly often compounds technical debt. The second is innovation versus resilience. Organizations seek experimentation and competitive advantage, yet production environments require reliability, observability, and risk controls. The third tension is governance versus shadow AI. Excessive governance can slow adoption, while insufficient governance encourages uncontrolled experimentation outside approved frameworks. Importantly, these tensions are not management problems alone. They emerge because existing architectures cannot simultaneously satisfy all competing demands. Sustainable resolution therefore requires architectural modernization rather than additional governance committees or project oversight structures. Although industries differ significantly, the architectural pattern remains remarkably consistent. In banking, legacy core systems constrain real-time fraud, credit, and AML decisions. In healthcare, fragmented clinical systems limit auditability and workflow integration. In telecom, legacy operational platforms restrict real-time optimization capabilities. In manufacturing, isolated operational technology environments prevent direct integration between AI and production systems. Across all sectors, the same conclusion emerges. Organizations can often deploy AI capabilities faster than they can operationalize accountability, governance, and control around them. This distinction is increasingly important because enterprise value does not come from deploying AI. It comes from operating AI reliably, safely, and at scale within core business processes. Leading organizations are beginning to rethink modernization entirely. Rather than pursuing large-scale replacement programs, they are treating modernization as an AI enablement portfolio. Each investment directly addresses a structural constraint. API strangler layers decouple AI services from legacy systems. Event-driven architectures provide real-time signals. Governed feature stores create consistency across model lifecycles. Observability platforms provide operational visibility. Governance as code embeds policy enforcement directly into decision flows. This approach delivers incremental progress while preserving operational stability. More importantly, it recognizes that modernization is not a technology initiative alone. It is an enterprise capability building program that creates the conditions required for trustworthy AI at scale. One of the most common misconceptions in enterprise transformation is that cloud migration automatically creates AI readiness. Cloud migration changes infrastructure, deployment tooling, and operating economics. However, it does not inherently resolve architectural debt. A monolith remains a monolith, even when hosted in the cloud. Batch processing remains batch processing. Governance limitations remain governance limitations. This explains why some organizations complete large cloud transformation programs, yet continue struggling to operationalize AI. They have moved the environment without redesigning the architecture. Executives should therefore distinguish between cloud adoption and architectural modernization. The two are related, but they are not the same thing. The final takeaway is that the future competitive divide in enterprise AI will not be determined by model access. Increasingly, most organizations will have access to similar AI technologies. What will differentiate them is their ability to operationalize those technologies within complex enterprise environments. Architecturally constrained organizations will continue layering AI onto fragmented systems and discovering limitations during scaling. Architecturally ready organizations will modernize deliberately, embed governance into operations, and create visibility across the entire AI lifecycle. Ultimately, enterprise AI is becoming a question of institutional readiness. The organizations that succeed will be those capable of operationalizing intelligence without sacrificing resilience, accountability, or governance. That is why architectural modernization is no longer simply an IT concern. It is rapidly becoming a board-level strategic imperative.